last video, we're still in chapter 6, section 5, dealing with translations of sine and cosine functions. We weren't quite able to finish our problem, okay? We were trying to take a sine function with the amplitude of 15, a period of 4 pi, and a phase shift of pi over 2, with a vertical shift of negative 10. Don't try to say that fast 3 times, all right? And we figured out what our A, B, C, and D were, but we kind of had to rush through the phase shift. So we're going to go through the phase shift one more time, in case you weren't able to catch it from the last video, all right? So the formula for the phase shift, everybody, is C over B, and we set our phase shift equal to the value of pi over 2. So we set it equal to pi over 2. This time, though, we replace the B value because we already found it to be a half. So I'm going to erase the B, and I'm going to plug in a half. But when we do our cross products right here, 1/2 times pi becomes pi over 2. All right? Or if you want to put a half of pi, you can do that. And that equals C times 2, also known as 2 times C. And this is where I kind of rushed through. I multiplied both sides by a half. And when you multiply fractions, you do top times top, which means the numerator times the numerator, and the denominator times the denominator. So our C value became pi over 4. So that right there is our C value. So right now what we're going to do is we're going to write our final answer with all of our numbers. We're going to put 15 or negative 15. I'm just going to use the positive 15 for our final answer. So remember, it's y equals A sine, open parentheses, B theta minus C plus D. So what was our A value? We could say we could choose a 15 or a negative 15, so I'm going to choose the positive 15. Because we all know positive numbers, right? And the B value is what? A half. What's a half times a theta? Half a theta, right? But you could also write theta over 2. So you could write theta over 2, which is the same as a what? A half of theta. They make the same thing. So we're just going to put theta over 2. We're going to put minus. What was our C value? Our C value was pi over 4. So I'm going to put pi over 4. I'm going to close the parentheses and put plus, and what was the D value? A negative 10. So instead of putting plus a negative 10, I'm going to erase this plus, and I'm just going to put minus 10. This is your final answer. With your A, your B plugged in, your C plugged in, and your D plugged in. Just remember, I said A was 15 or negative 15. I said the B value was equal to a half. I said C was equal to pi over 4, and D simply equaled a negative 10. And that's your final answer for problem number 5. Now what we're going to do, we're going to go down to a graph. Let's take a look at problem 8 and zoom in. How do we interpret a graph? This will be the last thing that we do today on this video. Interpreting this graph. And number 8 asks us to find if it's a sine function. Okay? So y equals A sine B theta minus C plus D. So we got to figure out what the A value is, what the B value is, C, and D. So let's take a look at this graph. And what's going to be the easiest thing to find in this picture? The A, the amplitude, and vertical shift. Very good. So right here, what does this line right here represent in the graph? That represents what's known as the midline, right? So where does that cross? It crosses right here at a negative 2. So right here for D, put minus 2. Because your midline, everybody, your midline is y equals negative 2. Let's look at our amplitude. How high does it go up from the midline, and how far does it go down from the midline? What's the distance between a negative 2 and a positive 2. 4 units, that's right. 4 units, but A equals 4. I'll change it to blue. Our amplitude is 4. That's 4 units. From a negative 2 to a negative 6, it also is 4 units. Okay, that's the amplitude. Right? Now, the b value deals specifically with the period of the function. Now, what's the formula for the period of a sine or a cosine function? That's right, 2 pi over b. Now, we got to figure out what the heck the period is. So, right here in a sine function, if I were to go to y equals, I'm going to y equals, I'm going to clear this out, I'm going to clear this out, I'm just going to go sine of x. Just look at it. Hit graph. Alright, so right here, look at the picture here. There it is. Look at the picture. This right here, from here all the way down and back up, that's a period for a regular sine of x function. From here going all the way down, that's it. That's also a period. Alright, so where does it usually start? It starts at 0, right? It goes all the way back to 0. It goes up and down and back up. Up and down and back up. So that's what we're going to interpret. Let's go back here. Ready? Down, back, up, right there. Everybody see that? So I want you to, right here, I need you to understand that from here all the way to there, that length, that distance is what's known as the period. So let's figure out how long that period is. From right here to right here, that's the period. Let's check. What's the gap from, like, say, here to right there? What's that gap? What's the distance between a 2 pi and a 3 pi? That distance is just pi units. So every single time you go from a 2 pi to a 3 pi to a 4 pi, that's what? That's a pi. Which means 2 spaces. 2 spaces right here equals 1 pi. Does that make sense? 2 spaces equals 1 pi in this picture. So in this picture, 2 spaces equals 1 pi. So we start here, ready? From here to here. What's the, right, from there to there? That's 1 pi. How about from there to right there? 2 pi. From here to here. 3 pi. From here to here. 4 pi. So from here all the way to here, what is our period equal to? 4 pi. So good. Our period is going to be 4 pi over 1. By doing that, what are we allowed to do now? We're allowed to take this and find its cross products and solve for b. Alright, so you have to find the period of the graph. So you got to figure out where does the graph start, where does it end in one cycle. So we cross multiply, you get 4 pi times b. 4 pi times b is one of the cross products. 2 pi times 1 is 2 pi. Divide both sides by 4 pi. And what is your value for b? 1 half. So b equals 1 half, because the pi's cancel out, and 2 divided by 4 is a half. Okay? So right here, I'm going to put my b is simply equal to a half. Okay? Now this is where the students sometimes they pause, phase shift. Okay? So let's look at our regular sine of x graph, right? And this time I'm actually going to go to y equals, I'll show you the window. I'm going to start at 0. Okay? So let's take a look at it right now. There's your normal sine of x graph. Right here, this is at 0, 0. That's where it usually starts out. So it starts out at 0, 0, then it goes all the way down and finishes at 2 pi. Well, let's look at our graph. All right? Let's go back and take a look at our graph. Does this graph start at 0 where the x values are? It doesn't, does it? It doesn't start right here, does it? Where did you see me start the graph? Just a little bit over to the left. This distance right here, everybody, that distance just barely to the left. What's one tick mark? One tick mark is between a 0 and a pi. One tick mark is half of a pi. But I didn't go a positive half a pi. It didn't start right here, did it? It started to the left. So what is our phase shift going to equal? Negative half of pi. That's our phase shift. It went from here to a little bit over. Okay? So right now, what I'm going to do is I'm going to make my formula for phase shift right here. Phase shift. Phase shift is equal to the formula of what? C over B. What was our phase shift? A negative pi over 2. That was our phase shift. What value do we already know? We already know which value? Our B value. What did we find our B value to be? Our B value was a half. So right now, I'm going to take 1/2 and plug it in right there. I'm plugging my 1/2 in for B. Now, let's look at our cross products. Ready? One of our cross products is 2 times C, which is just 2C. Our other cross product is a negative pi times a half, which is just negative pi over 2. Negative pi over 2. The same thing as saying what? Negative half of pi. They mean the same thing. Now, to solve for C, I'm going to take this side, I'm going to take this side, I'm going to multiply this by half, I'm going to multiply this by half. You can always remember, whenever you're solving, you can divide both sides by 2, or you could multiply both sides by its multiplicative inverse, or its reciprocal, which is 1 over 2. And C is equal to a negative pi over 4. That's what C is equal to. Now, the phase shift was what? The phase shift was a negative pi over 2, right? But the C value is equal to negative pi over 4. So right here, I'm going to go right up here where it says C, I'm going to put negative pi over 4. So have those down because we're going to write our final answer right here. Okay? Here we go. Final answer. Y equals, what was our A value? 4. Open parentheses. What is our B value? 1/2. So what's 1/2 times theta? You could just write theta over 2. If you put 1/2 of theta, that's fine. But the thing is I want you to know that 1/2 of theta means the exact same thing. Theta divided by 2. So they would probably, on a paper or an assignment or a quiz or a test, then most likely you're going to see a theta over a 2 versus a half of a theta. I'm going to put minus my C value. What was my C value? Close. My C value was what? A negative pi over 4. What's going to happen to those two negative signs? Yeah, so right here, so instead of saying a minus in your formula, what are you going to put right there? You're going to put a plus. You're going to close it, and at the very end, you're going to put a minus 2. That's your final answer right there for problem number 8. What did we interpret? We interpreted the amplitude, which found us our A value. We interpreted the period, which helped us find our B value. We interpreted the phase shift, which helped us find our C value. And then the D value is the easiest part. That's just your vertical shift of